All right, let's talk about some properties of whole number multiplication. And these properties, you'll notice, are very similar to the properties that we saw when we looked at whole number addition. Okay, so let's start with the closure property. If A and B are whole numbers, then the product A times B is a unique whole number. So if I multiply any two whole numbers, I get another unique whole number back. The commutative property of multiplication says that if A and B are any two whole numbers, then it doesn't matter what order I multiply in. So A times B is equal to B times A. Okay, same idea as with addition, right? Remember, with addition, the only difference here was instead of the times between the two numbers, we had plus. The associative property says if I have whole numbers A, B, and C, then if I'm multiplying, I can first multiply A times B and then multiply that by C, or I can first multiply B times C and then multiply that by A. All right, so that's the associative property. The identity property says that there's a unique whole number 1 in this case, such that for any whole number A, if I multiply A times 1, I just get A back, and that's the same as if I multiplied 1 times A. So the identity is always a number that when you perform the operation on with any other element of your set, you get that element back. Okay. All right, this is new, the zero property of multiplication. If I multiply A times 0, what should I get? I should get 0 back. And finally, we're going to introduce the distributive property. So A times the quantity B plus C is the same as A times B plus A times C. So I can distribute the multiplication over that addition. All right, let's think about closure. So are the following sets closed under multiplication? So let's look at set A first. If I multiply any two numbers in set A, do I get another unique number in set A? In this case, yes, A is closed under multiplication. Why is that the case? Well, A is the set of even whole numbers, right? And if I multiply any two even whole numbers, I will get another even whole number. Which must be an element of A. What about B? Is B closed under multiplication? So if I multiply any two numbers in that set, do I get another number in that set? So after looking at those numbers for a second, the answer should be clear to you that the answer is no, and you could pick any number of examples. For example, let's just do 2 times 3 is 6, which is not an element of B. So it's not closed under multiplication. All right, let's make sure we can identify properties. What property is being illustrated here if I say 3 times the quantity A plus B is equal to 3A plus 3B? This is going to be the distributive property of multiplication over addition. How about y plus 2 equals 2 plus y? Well, here I'm switching the order of addition. So this is the commutative property of addition. Okay, so make sure now we've got several operations. Make sure you're clarifying what operation. How about 21 times 1 is equal to 1 times 21 is equal to 21? That's my identity property of multiplication. Three times 2 times b is equal to 3 times the quantity, 2 times b. You can see here I've moved the parentheses, right? That's our associative property of multiplication. All right, and last equation. I have 3 times the quantity 4 plus 2 equals 3 times the quantity 2 plus 4 equals 3 times 2 plus 3 times 4. What's happening in this first equality? Well, I've switched the orders of my addition in the parentheses. That's the commutative property of addition. And in this second equality, I've distributed, right? I've distributed that multiplication over the addition. That's my distributive property of multiplication over addition. All right, finally, I just want to show you some illustrations of those properties. So here we're using the array model to illustrate the commutative property of multiplication. We can illustrate the associative property of multiplication here with a 3D array going. And the distributive property also with our array model. Right, so here I have 5 times the quantity, 3 plus 4. I can break that bottom into 2 separate rectangles of width 3 and 4. And you can see that if I add up the number of squares on the left, that's the same as the sum of the number of squares on the right. All right, so we can also distribute multiplication over subtraction. So a times the quantity b minus c is going to be ab minus ac. And we can write our distributive property sort of in reverse. So distributing on the right, b plus c times a is the same as ba plus CA, so I'm just distributing that A on the right. And we can generalize the distributive property to any number of terms. So it doesn't have to be just B plus C. Maybe I have B plus C plus D in my parentheses. When we write the distributive property going the other way, so AB plus AC equals A times the quantity B plus C, you can think of that as pulling this A out of each term. That's called factoring, right? So we are getting students ready for algebraic thinking in the early grades. And so we want them comfortable with this property so that when they hit factoring up in the upper level courses, they are all set, ready to go. All right, the factors of AB plus AC are A and B plus C. All right, let's try using an area model to show that x plus y times the quantity z plus w equals the right-hand side. So what am I going to do for an area model? Now I'm going to be a little careful because we don't know what these numbers are. So let's call this x plus y on the left. And this is z plus w on the bottom. And now let's just split these so that this is x and this is y. And I want to think of this as z and this as w. Then what happens inside each of these rectangles? Well, this rectangle on the upper left side has width z and length x, so this is going to be xz. The one on the upper right is xw. On the bottom left, I have yz and then yw. So x plus y times z plus w equals xz plus xw plus yz plus yw, based on my picture. I'm going to let you try the second problem on the bottom. So we're showing the same equality, but I want you to use the distributive property of multiplication over addition. So you should start with the left-hand side, x plus y times z plus w, and start by distributing x plus y over that second sum. So I have x plus y times z plus x plus y times w, and you should keep going, okay?